Welcome to Link G4 Plus Training Part 19. In this video, we're going to be taking a look at our open loop style boost control. We're going to have a lot to learn, so let's get started. Okay, so let's jump into this video and start talking about our open loop style boost control we're going to be finding with our Link EMS. So we have the ability to control a boost solenoid. Now the boost solenoid is going to be a pulse width modulated output, and it's going to be allowing us to increase the amount of boost from our wastegate spring level. Now we're going to have two kinds of boost controls. We're going to have an open loop or a closed loop style control. In this video, we're going to be focusing on the open loop style control, and that's going to be where the Link just allows us to program the duty cycle to control the boost solenoid to increase the boost. There's going to be no feedback coming from the Link to try to get up to a target boost level. There's not going to be a target. We're just simply going to be adding more duty cycle to get more boost, or reducing this duty cycle to have less boost. It's going to be relatively straightforward, but there's going to be a lot of details that we need to know in order to pull this off and make it work correctly. So in this video, we're going to be going in, creating a custom page layout for our open loop style boost control. I'm going to be walking you through all the details you need to know and all the different configurations and types of boost control that we can use for our open loop style control. So without further wait, let's jump in so we can check this out. All right, let's get started here. We're going to be taking a look at our open loop style boost control with our PCLink software here. So the very first step we're going to be taking here is creating our custom page layout to do our open loop style boost control. We're going to go up here, right click, new page, type in open loop boost, and now we have our blank page to start. So we're going to be jumping up into ECU settings here. We're going to be going into boost control and then into boost setup. Let's go ahead. Let's double click that and open up our window, slide our window up into the upper left hand corner here. Let's lock it into place. Let's go in and bring our window up here and trim it to fit a little bit better. We're going to go into boost mode next, and we're going to go in, double click this. We can see we have a status of off, open loop, or closed loop. We want to go select our open loop boost for this video. We're going to be taking a look at our closed loop boost in the next video. There is going to be some differences in the open versus closed loop. It's going to be a little bit more complicated for the closed loop control, and what we learn here in the open loop will apply to that closed loop, and a lot of the setup is going to be the same here. So I'm going to go ahead and select this open loop right now for our video, and it's going to go ahead and populate there. So we're going to be going up into ECU settings next, going into multiple boost tables, double click multiple boost tables. We're going to be dragging our new window up here, our setup window, be underneath that, and then sizing it down, locking the window. Go to active tables, and we're going to be going up here first, jumping into interpolate between. I'm going to go in here and click OK. And it's going to ask us if we want to clear the wastegate 2 duty cycle table out, make it 0, and set the axis to default value. Say yes. And we're going to be going to boost table ratio table. Double click our icon here. We're going to be seeing we have a table populate, and we want to go ahead and slide that up underneath here and bring our window up. And then we're going to be locking this and locking this into place. Next, we're going to go to active tables here, and we're going to be going in, and we can set it on 2 tables. And what we're going to be finding is this table will drop out here, show no data. We jump into ECU settings. We go into our, let's go here, our wastegate. We're going to see have a wastegate 1 and a wastegate 2 duty cycle table. We're going to first open up our wastegate 1 table here. We're just going to bring this up into the top of our screen. We're going to stretch this out here a little bit. And we're going to go and lock this window and actually scrunch this up a little bit. Then we're going to go to ECU settings, jump into wastegate duty cycle table 2, double click, bring this up underneath there, and we're going to go stretch it across and bring it up here a little bit. Now these 2 tables here are going to represent where the duty cycle comes from. We're going to be seeing how these work a little bit later in the video here, but we need to have both up on the screen. I'm trying to give you the most efficient layout here, so you can see the most amount of data and really keep track of what's going on. It's going to be a lot easier to work with everything here. So now we've brought these 2 tables into our window. We're going to jump into ECU settings. We're going to go to boost IAT wastegate trim value, or trim table. Double click this. We're going to go here and slide this up underneath the boost ratio table and trim this up into place here to give us some room. Lock this into place, and we're also going to lock this window. Go to ECU settings, go to boost ECT wastegate trim, double click that. We're going to go ahead and bring this underneath that window right there. We're going to do the ECT under the IAT window. and size this into place, lock this, lock the window. Go to ECU settings. Go to boost gear wastegate trim table. Double click that. We're going to be bringing this up underneath and again trimming it into place. Now these three tables are going to represent the trimming factors that we can do based on either air temp, coolant temp, or boost by gear or gear position. So we have the ability to either add or subtract duty cycle in our open loop style control we're going to be seeing. It's pretty straightforward how it's all going to work. I'm going to be walking you through how exactly it works and what the values represent, but these are going to be modifier tables based on these conditions. So next we're going to go up here, we're going to go and right click, new view. We're going to be going into our runtime values list. This is going to be our real-time values that we can watch if we're just simply doing tuning and we're not doing data logging. So we're going to go into a runtime value list and we're going to wait till this opens up here. And now we're going to be ready to add the values in. So our first value we're going to be typing in here is going to be engine. We're going to look for engine speed here. We're going to add it. Next, we're going to be typing in our manifold air pressure, or MAP pressure. And we're going to add this to the window. Go up here to MGP, manifold gauge pressure. I'm going to go ahead and add this as well. Next, we're going to be typing IAT for intake air temp. We're going to add this to our window. We're going to be typing ECT, engine coolant temp. Adding that to the window. Next, we're going to go in here and type in gear. Look for gear status. I'm going to add that. Next, we're going to be doing boost target. This is going to be looking at what our boost is actually at here. And this may not be used for open loop. It's for closed loop, but we'll still want to have that added there. Next, we're going to do active. Type in here active boost table. This is going to tell us the status of what table it's using, either the wastegate 1, wastegate 2, there's even a wastegate 3 duty cycle table that we're not going to be utilizing and showing in this video, but the concept will be the same. You'll understand where it's coming from. So we want to know what table is active at any time. We're going to be typing in ECT again. We're going to be looking for ECT wastegate trim. And the ECT wastegate trim is going to be reporting how much percentage trim is coming from our ECT wastegate trim table. We want to keep an eye on that. We're also going to be typing in IAT. We're looking for our IAT wastegate trim. Again, it's going to report what's coming from this table, so we're going to add that. And we're going to be going in here and typing in gear. And we also want to watch our gear wastegate trim. If we go down to the bottom, maybe we are looking for gear wastegate trim right here. And we're also going to be going in and looking at our actual wastegate. So we'll just type in WG. And we want our W gate duty cycle, so wastegate duty cycle. This is going to be what's coming out after it goes through these tables here. So whatever's commanded in whatever active table for duty cycle to send to the solenoid, and after it gets filtered through and modified from these tables, it's going to be what actually comes out. So it's important to also watch what's going on with that. We're going to be adding a few things in a second here, but let's go ahead and click OK and let our list populate. And let's go stretch this out a little bit and bring this down a little bit. We'll bring it down to right about here. That's sufficient. And then we can bring our windows for our wastegate 1 and 2. Let's bring these over a little bit. Let's bring that back. Now, what we haven't done yet, and what we need to do, is go in and set up. Let's go. Yep, there we go. It's in place. Let's lock these now. Is go set up our actual output for our boost controller, the aux output. So we're going to jump into ECU settings. We're going to go up here to our auxiliary outputs, and I'm just going to say my aux 6 is my boost solenoid output. So I'm going to click my aux 6. I'm going to go into function here, double click it from off, and we're going to be selecting here boost solenoid. Click OK. And it's going to go label here. We'll type in here boost solenoid and click OK. And then the frequency we can leave here at 30 Hertz. We have the ability to go in and modify this frequency if we find that the duty cycle that we're entering in the table is giving us large jumps in boost. So 2 or 3% duty cycle gives us something like 4 or 5 pounds of boost increase. That's going to be too sensitive, and we have to then raise the frequency here if we find that we can't get enough boost out of our table here. If we're at 99% duty cycle and we want more boost, we're able to go in and lower the frequency down. It's going to be depending on how much we send out for frequency, in conjunction with the actual duty cycle here, are going to be how much boost we have, or the range of boost, or the resolution of the boost control. So the higher the value here for frequency, the more fine the control will be for a given duty cycle, and the lower the value here for frequency, the more coarse of adjustment. So a small change in the duty cycle gives us a large change in boost. So we have to keep that in mind when we're working with this, but typically we'll start here with a value of 30 hertz. So let's go ahead and we'll close this. We don't actually need that open now. We've defined that. But what we want to do here, right click back onto our live list here, properties. We're going to be looking here at, let it populate here for a second. We're going to be typing in boost solenoid, specifically looking at the status there of what's going on. So we'll type in boost and we'll let it populate here. And we're going to see A6 boost solenoid. We're going to look at the status. And we're also going to be looking here, we also have the active boost table, we've added that already. We can see that our boost status here, we can also add that and click OK. So we have those in this window right here. Now we're going to go next, type into, or go right click I should say, new view. We're going to go down to our parameters list. And then we're going to go to our add parameter here. We're going to add a lot of the same data we found right here into our logging list. So the parameters list is going to be meant for data logging. So as we play back through our actual time plot, it's going to be showing us the parameters here. So let's go in first. We're going to type in engine speed. And run down here, grab engine speed. Add parameter. We're going to next add our map sensor. And we're going to be typing in map. Next, we're going to go to add parameter and type in MGP for manifold gauge pressure. Go ahead and select that. Next, we're going to go to add parameter and type in IAT into air temp. And type in IAT. Grab that. Add parameter again, we're typing ECT. ECT, and we'll be grabbing that. Next, go to add parameter. We're going to be typing in our gear. Grab gear status, click OK. Add parameter, we're going to be typing in our boost target. And click OK. Add parameter. We're going to be looking at the active tables here. Next, we're going to be doing active. Type in active. We're going to be seeing which table is being used at any given time. So our active boost table. Click OK. Next, we're going to be typing in here our ECT wastegate trim. So we want to have the wastegate trims reported. We're going to be looking at all of these here. We're just typing in WG. And we're going to be able to select all these now. We can just select all of them in a row. Click OK. And then finally, we want to know what our lambda is doing. Let's go ahead and add parameter. Type in lambda. Looking at lambda 1, and we also want to know what the correction's doing if we're in closed loop. So we're going to go in here and add another parameter. Type in again lambda. We'll look at our lambda correction here, see what it's doing if it's in the closed loop status. And then finally here, we're going to be looking at our ignition timing while we have it up in our logging list. And we're going to be typing IGN for ignition. And we're going to be looking at our ignition angle, which is going to be our final corrected timing amount. So click OK. Now we have our parameters list here built. Let's go ahead and bring it up into place. And let's go ahead and stretch the window out here. And then finally, we're going to go here, right click, new view, go jump into our time plot. And we're going to go bring this up here. Add group, first group, add parameter, engine speed. Type in our RPM. Grab our, we actually have to type in engine RPM. Doesn't like RPM alone. That'll give us engine speed. Grab this engine speed. Go to add group. Add parameter. We're going to be typing in our map pressure. Grab that. We want to see what the boost is doing while we're doing our tuning. Next, do add group, add parameter. We're going to be typing in wastegate. We want to know what the wastegate output is doing. Wgate DC, wastegate duty cycle. And then lastly here, add group, add parameter, and we're going to be typing in what gear we're in. We're going to be finding that we can use gear reference tables pretty successfully, so we want to watch what our gear position's in. So let's go to status, OK. And finally, it's going to go ahead and add it, so we'll just wait till that goes in there. We see gear, click OK. Now we have our time plot set up here to look at some data log with some data in it, and we're all set up now for our page layout. So let's make sure we go through, we lock all of our windows into place so they're not going to move, and even into our live list here. So now we've set this up and we're ready to start taking a look at how this is going to work. Okay, so the next thing we're going to be doing here is making sure we actually save our layout. So go layout, save layout as, and we're going to be going in here. I'm going to save mine as my EPA demo layout, save, and now we have our layout saved. So what we're going to be doing here, go to multiple boost tables. Let's set this back to one table. Once we do that, we're going to be seeing that wastegate 2 drops out. We want to make this as simple as possible to break down how this works and what we're going to be looking for when we're doing our boost tuning. So the first thing they're going to be doing here is going into RPM activation up in our boost setup. This is going to be the RPM point where the boost solenoid is allowed to turn on. So we can see right now A6 boost solenoid is in the status of off, and our duty cycle here is at 0. It's coming from our table, or would be coming from our table here at a value of 0. So let's go in and just quickly just populate those some values here. So when we go in, have the status turn on, we can see that everything's going to turn on here. So let's just pop in a value of 20% duty cycle in the table there. It's just an arbitrary amount for right now, so we can illustrate what we're trying to show. Okay, so we're going to be seeing that if we're below 2000, the solenoid will not turn on, and it's the boost status is going to be reporting what's going on with the output. So we can see we're in an RPM lockout. That's because this RPM here is right now we're at 1800 and it's set at 2000. So I'm going to go and bring my engine RPM above that. Now we can see we're higher than the activation, so it should be active, but now we can see that we're in this map lockout, and that's because we have a map activation here at 100 kPa or 0 psi. We can see that our map pressure is at 88 kPa, which means we are operating in vacuum. So we want to make sure that we don't pulse our solenoid and can try to control it when we're driving, let's say, an idle or driving at part throttle, because it's going to wear the solenoid out. It's going to be unnecessarily putting stress on the solenoid as it's pulsing it. Over time, it could wear the solenoid out and cause it to prematurely fail. So normally we go and set our map activation here at 100 kPa. That'll be sufficient, again, so we don't go in and damage the solenoid. So if I'm going to be bringing my map pressure here, I'm going to go and bring it above. We can see as soon as I do that, we go up to 103 kPa, which is just barely above 100 kPa. We can see that boost status now is an open loop. It's reporting it's set in this boost mode. It's reporting it's an open loop. Our boost solenoid is sending its output out. We can see its status is on. We can see that our active boost table here is coming from table 1, which is our wastegate duty cycle table 1 here. And then we're going to be seeing that the output, our wastegate duty cycle here, is 20%, which is coming from the table here. So depending on what we change this to, if I go in here and I set it to a value, let's say, just changing it to a value of 30%, we're going to be seeing once we do that, it changes here, wastegate duty cycle 30%. So let's move into the table here. So what we're going to be finding is that the duty cycle that we plug into the table at any given point is going to either increase or decrease the boost pressure depending on what our wastegate duty cycle is going to be set at. So if we start off doing any of our tuning for boost control, we're always going to want to go in here and zero out this table, make this entire table 0. That's going to baseline the lowest boost pressure we're going to be able to achieve. So it's going to be our wastegate spring pressure or our wastegate actuator pressure if we're on a internally wastegated setup. So we want to start off with a value of 0. Now, if we go in and we start to increase the values here, let's go from 0, and then if we go, let's go in here to 20%, let's say, we're going to be noticing that as we jump up in duty cycle, it's going to start to increase the boost. Depending on the solenoid, you might notice that it doesn't do much of anything until you get up to maybe 20 or 30%. Some solenoids, such as a 4-port solenoid, you might notice that it starts to respond and increase the boost as low as 10% duty cycle. So everything's going to be a little bit different. I normally walk my boost solenoid duty cycle up here in about 10% increments when I'm doing my tuning with a 3-port. If I'm using a 4-port, I'll usually walk it up in 5% increments. So it might go from 20 to 25, then 25 to 30, because it's going to give me a larger change in boost. It's going to be more coarse of an adjustment. Now, kind of going back to what we talked about when we set up our boost solenoid, if we're finding as we're putting values in here, going from let's say 20 to 25%, and we notice that it jumps 8 pounds of boost or something that's an extreme amount, so it's a very coarse adjustment, we're going to want to go back into our ECU settings here and change the frequency. We go into our auxiliary outputs, whatever the pin we've added it on. I have it on my aux 6, and you can see that's why I have it selected here, A6 boost solenoid. If we double click on this, it's going to open up our window, our setup window, and we're going to be finding that our frequency here is set at 30 Hertz. We can change this. So if we're finding that small duty cycle per changes give us large changes in boost, we can go in here to our frequency and raise this, maybe go from 30 to 50. We're going to be finding that it's going to give us a finer control as we change our duty cycle value here. So it's going to be one technique I wanted to point out. A lot of people don't talk about that, or it's something that's not really understood. We don't have to drive the solenoid at the frequency that it was designed at. We don't have to operate it at 30 Hertz or at 20 Hertz or whatever the frequency level is going to be at. We can manipulate that to kind of get the response that we want and the resolution of control. So let's jump in here to our table. Now that we understand that it's just a simple duty cycle lookup, and it's going to be between 0 and 100%. So 0 being all the way off, 100 being as much as the boost solenoid can flow to the wastegate to achieve the highest boost pressure possible. So if we put a value of 100 in here, we can't get any more boost out of it. It is what it is. So if we go in to configure our table, if we click X here on this table, we're going to be finding that we have the ability to go in and change our breakpoints on the table and define how this table is set up. Now, normally what I do if I'm doing the boost control for open loop for a race vehicle, I'll either do boost by gear and boost by gear and engine RPM, or I'll do boost by gear and I will do it based on ground speed. So if I have a ground speed wired in, I'll have those two different choices. So let's just check this out here. I'll leave this on engine speed, but on my y-axis, I'm going to change this to gear. So I'm going to go up here, go up into my status. I just click this icon right here. Double click it, and we're going to be going in and changing this. We'll type in up top here gear, and we're going to run into gear status. Now we can only use boost by gear if we've set up our gear. We've walked you through how to do that in another video, so you should be understanding how that process is going to work. So we established what our gear is as we're shifting. So I'm going to go and clear all these breakpoints out. I'm just going to select all of these, go in here and grab them, and use the shift key and use my down arrow. And then I'm going to go and click X here, delete each one of these breakpoints. Then I'll go scoot up to the top of my table, start my first one here at 1, then go to 2, then go to 3, then go to 4, then go to 5. Oh, cancel. We'll go back to the next breakpoint, to 5, and then 6, and then click OK. Now what we can find is we have our table defined on the engine RPM and the gear. And this is going to allow us to ramp the duty cycle in as we start to accelerate in a particular gear. So in first gear, we might find at the lower RPM points, we might want to go and have our wastegate, the boost control, I should say, right off our wastegate spring. So we probably have it something like 0% duty cycle. And then as we get up into the engine RPM, we could ramp in the duty cycle, which then ramp in the boost. So it would be a progressive boost as we go faster in the engine RPM band in that particular gear, which is going to be a linear increase in power management. It's going to allow us to put the power down more efficiently, so we can go and just ramp this in here. So let's go ahead. I'll just
select this and go ahead, Shift H to horizontal interpolation. Now when I click into second gear, I might find that I can go in here and go and feed some more duty cycle in. So maybe at the top of second gear, we might go up to something like 35% duty cycle. And again, I would go and just highlight across here and bring the boost in, the duty cycle in with boost. And then third gear, maybe we go and have a higher duty cycle. Maybe we go and have 40% duty cycle. Now, we don't know what amount of duty cycle is going to correlate to amount of boost. That's going to be changing on your engine type, your turbo, your wastegate spring, how many wastegates you have, your wastegate position. So it's very imperative that you go and zero this table out, have 0% duty cycle before we go and try to do any kind of control. So we zero this out, baseline it, what it's going to be. Do we have boost creep? What is the wastegate spring? Even though we put a 10-pound spring in, it may only be holding 8. Is it holding 10? Is it holding 12? What is it? What is the boost, the minimum boost going to be? And then we're just going to manipulate this duty cycle to get the boost that we want. So we're just manipulating the duty cycle in a boost by gear table like this to achieve the boost that we want in each gear and allow the boost to ramp in and ramp the power in to put the power down to the ground more efficiently. So we have a lot of control over traction setting up a table like this. Now, one disadvantage to having a table like this is going to be that we have engine RPM on our x-axis here. And what's going to happen is, as we're feeding the duty cycle in as we go up in the engine RPM, if we go and overshoot the amount of boost that we want to run in there, and we don't have traction control turned on and configured, we're just running no traction control and just trying to do our traction management with this boost by gear table. If we feed too much duty cycle in, it's going to go and put too much power to the tire, to the grip surface that we have, and it could overpower the tire and put it into wheel spin. In this case, we could go in and start to deliver too much power as the engine RPM goes up, too much boost, which could then put it into more wheel spin. So it's going to be a vicious cycle of feeding too much duty cycle in because the RPM shoots up because we're spinning, and constantly going in and ramping up the duty cycle because we have that our engine RPM shooting up because we lost traction. So it's going to be something that we may not want to go and have our table configure with engine RPM. So another method that you can do, if you wire in a ground speed sensor, so we've set it up on a non-driven sensor, non-driven wheel speed. If we click X, we can jump into the X-axis, go up here, double click on our parameter here. Let's change this. We'll be changing it to non-driven wheel speed versus our gear. So we can go in type in non-driven wheel speed, click OK, and we're gonna have to go into the table here and redefine all of these points. So we're gonna go, I had my shift key, I used my right arrow, I highlighted all these, then I'm gonna go in here with my X, and then just hitting X every time I wanna delete a breakpoint. Now we can see that they're all been deleted. So I'm gonna go start at 0 miles an hour, and I might have a bunch of resolution here at 0, 5, 10, 20, 30. I'd probably want to have a lot of data points for the lower wheel speeds. That's going to be where we're going to be traction limited. So we'll type one at 40, 50, then we might do one here at 75, and do one here at 90, and then do one here at maybe 110, and then do one here maybe at 150. That should be sufficient for data points. And then click OK, and we can see now the table is configured based on our non-driven wheel speed. So at any given gear, we're going to be finding that we have a correlation to the wheel speed that's going to be relevant for that gear. So for example, first gear here, we're going to be seeing that typically between 40 to 50 miles per hour. Now we're in kilometers per hour. We have to change our unit type here, but typically if we're in miles per hour, it'd be between 40 to 50 in first gear. So as we ramp up in the range here, as we're getting our ground speeds picking up in first gear, we're going to be finding that we can feed that duty cycle in. And in this case, because it's a non-driven wheel speed sensor, it's going to be a consistent variable. So regardless if our front drive speed starts to spin or engine RPM shoots up if we're starting to get wheel spin, it's going to be operating at the same duty cycle. It's not going to feed more duty cycle in. So it's going to be my main method that I use for doing drag cars or any kind of fast kind of street cars, or I'm going in and dialing in traction limited. When I want to do it based, again, on this non-driven speed versus gear. That's going to be an excellent way to set up your boost control. Now, we don't have to have it based on gear. We're also able to just base this just on non-driven wheel speed. If you just want to have a two-dimensional table and get rid of your gear as your axis, but we have that ability to have a three-dimensional table here, we might as well take advantage of it. Now, one thing to note is that you have enough table spots in your allocation. Jumping into ECU settings here, you always want to go down and make sure as you're making this a three-dimensional table like this, you want to make sure in your table allocations that you have the ability to add that and you have the spots available. You don't have all of your spots pegged here. You have 30 tables in three-dimensional format that we can add. So we want to make sure that we have that available. We know what our limitation is. So if we're trying to go and save table allocation spots for other places in our calibration for that three-dimensional tuning tables, we may want to go and simplify these if you don't need this complicated control. So now that we understand how this works and we understand where the values in the table are going to be coming from, I'm actually going to go in here and I'm going to go and set my active tables. We'll jump on active tables. We'll go and set it on 2 tables. And when we do this, we're going to be noticing it's going to ask me if I want to clear out the default values of my wastegate duty cycle 2 table. I'll say yes. It's going to just put it back to the default values. My wastegate duty cycle 2 table will now be what activates when we go in here and we have this input switched. We can see digital input 1 is what it's set on right here. If I set it here to digital 2, we're going to be seeing that it switches the status here. It goes from active to inactive. So wastegate 1 now is active, wastegate 2 is active. So we actually have to go and configure this for a switched input. So this will allow us to do a high and low boost for boost control. So if we wire in a simple toggle switch to our link, we set it up on our digital input. If we jump into ECU settings here, and let's go ahead and collapse our auxiliary outputs, go into our digital inputs here, go into digital 1. So I've wired a simple toggle switch into my digital 1. So I'm going to go into function. I'm going to be setting this to a GP input, general purpose input. Click OK. Label, we'll be going here, call this boost switch. Latch input, we're going to go here, and we're going to be putting the latch input to off. Actually, we're not going to be using the on status, the pull-up resistor. Because this is a ground switch in, so it's going to be grounding the pin, we have to use the pull-up resistor. If we're going to be sending a 12 volt into this particular pin in digital 1, we're going to make sure that we turn that pull-up resistor off. The on level we're going to be setting as low because we're going to be grounding the pin. Activation edge, we'll be setting this to falling. Click OK. And let's go ahead and close this out and click yes. And then what we're going to be doing here, let's jump back into our parameters because I've wired it into digital 1. I'm going to go right click, go into properties, and I'm going to be typing in my digital 1 here and adding it to my channels list so I can see my status of that on-off switch so I know what's going on when I turn it on and watching my activation. Now we also can watch the tables go active or inactive, and we can look here at our active boost table. It'll report to us what table is actually active, but it's also nice to be able to pull this up on our status list here. So I'm going to be typing in here, actually I can just look here on digital inputs, and I can look at my digital 1 here, my speed 1, and we'll add it right here. And if we go here, let's type in boost switch. We're able to, let's let it populate here a second. We're going to be able to add it to our digital 1 boost switch status right here and click OK. So now we can see that it's here. So what I'm going to do is push my button right now and see what it's going to go reach. So it should say from off to on. So you can see it's active, now it's off, now it's on. So I've turned the switch on and it's activating or it's grounding the pin. So again, this is a simple on-off toggle switch. One leg goes to my ECU pin, the other leg is going to go to a chassis ground. So it's simply just going to be grounding the ECU pin. So if I turn it off, it turns off. So now we know it works. So what we're going to be doing now is go into a table activation, set it on active, double click this, set it on active 1. So our digital input is our activation source. So now when I hit the switch, it's going to go in here and we can see that it's going to go active and then it's going to go to table 2. Let off the switch, turns off, table 1 is active, and go back in, table 2 is active. So depending on where I'm at, it's going to be sourcing the different tables. And we can also see that go from active to inactive state. So this is going to allow us to have a bunch of different flexibility and control. We are able to set these tables the same. So let's just say, just for like consistency's sake, I'm going to be setting all of the tables here. Let's go ahead, click X, and let's go into my Y-axis. I'm going to be setting them the same. And we're going to be able to see that we can have 2 different boost by ground speed or non-driven wheel speed tables. So we're going to have a low and a high. We have a ton of flexibility here. So I'm going to be typing in a gear. Type in gear, click OK. Again, let's highlight all of my breakpoints here, all the way down the table. Using my X, clear them all out. jump to the top of the breakpoints. We're going to do 1 at 1, 2. Let's do the skier positions. Let's do 1 at 3. Let's do 1 at 4. Let's do 1 at 5. Let's do 1 at 6. Now in our parameters up here, we're going to be typing in our non-driven wheel speed. So we're going to go double click this, and we'll do non-driven wheel speed. And we want to make our axes the same. We want them to be identical because if we're going to be switching between two tables for lookups, it's going to be nice to be able to simply have the exact same table mirrored in our table 2 for our breakpoints, and then we can just set up everything accordingly. So I've highlighted all this. It'll clear these all out. I'm going to be setting my breakpoints the same as my Wastegate 1 table here. So I'll go to 0. We do 1 at 5, do 1 here at 10, do 1 at 20, do 1 at 30, do 1 at 40, do 1 at 50, and we'll be doing the next one at 75, then do 1 at 90, and 1 at 110, and here at 1 at 150, and click OK. So now we have identical tables. So if we put a value in here, we could probably copy the values into this table if we choose to do so. Let's go in here. Let's highlight this, go right click, go in, and we're going to be looking for our copy function, cell copy, and it looks like we don't, oh yeah, here, copy selection, Control C. And let's go back into our table now. Let's go and do Control V. And now we've copied it. I'm going to click Control S and save this and perform the store feature so I don't lose this. We're going to be finding here, let's actually make all these values in the first row the same. Let's just make them 20, and let's make these 20. So we're going to have two tables now that are identical in the way they're set up. And we're going to be finding that because we can switch between these two tables, we are able to go in and have a boost by gear versus the non-driven speed table here set up so we get optimal traction. And then maybe we want third, fourth, and fifth gear. Let's go ahead and make these all value of 40%. We're going to be finding in third, fourth, and fifth gear, maybe we want to go and have, let's say 40% duty cycle gave us 15 pounds. Maybe we want to have 22 pounds. Let's say 60% duty cycle gave us that amount of boost. I'll hit Control S and perform that store again. What we're going to be finding is our Wastegate duty cycle here shows 20. When I go and I push my button, it's going to be showing 20 here. Now, if I go and I change this value to something like 40, we're going to be seeing our Wastegate duty cycle now is reported at 40. So it's going and reporting whatever I put into this table. If I let go of it, it goes back to table 1, a value of 20% duty cycle. Pretty straightforward, but you can see that you have now this flexibility of just simply wiring that toggle switch on. When you flip the switch on, it's going to go and flip to this next table here, give you a higher boost level or a lower boost level depending on how you set it up. It's going to be up to you with the flexibility with this, but you have the ability to do that. Now we have if we look here, our table activation, or active tables should say, we also have this 3 tables. If we choose this and click OK, we're going to be finding here, let's click yes, we're going to be finding that we also have a Wastegate duty cycle 3 table. ECU settings here, let's jump in and jump back into boost control. Go down here, you can see Wastegate duty cycle 3, it's inactive at this point. We're going to be finding it has the same kind of flexibility. If we had another switch, we could have a third Wastegate table that we could activate and toggle between. So we'd have Wastegate 1, Wastegate 2, and then finally a Wastegate 3. We don't need to have that much control. I've never really needed anything beyond a simple high and a low, especially if I'm doing gear-based and non-driven speed-based here tables. I have a ton of flexibility. I don't need to have a third table, but we have the ability to do that if we choose to take advantage of that. So let's take a look here at the last option that we have with our boost control. So in active tables here, we're going to go into interpolate between. We're going to be seeing now that actual table 3 went and disappeared. It's only going to be using now this Wastegate 1 and Wastegate 2 tables. And we can see in this case, it's going to be showing that both are active. And it's doing that because it's using now this blend ratio between this table, this blend table. Now, this is useful for flex fuel, and when we do our flex fuel training video, we're going to be looking at how this works. But right now, I'm going to be illustrating this in a different manner. We can use this blend ratio table if we want to use a trim pot. So we're going to be having a multi-position trim pot that each click is going to allow us to have a different position on this table here. So let's actually go into our ECU settings. If we jump into our analog inputs, we're going to be finding on our analog 6, if we double click this, I've wired in a trim pot. And I've set the function on my list here to a 0 to 5 volts. So voltage 0 to 5 volt. So the trim pot, every time we click the position on the next switch, or the switch position I should say, from 0 to 1 to 2 to 3, it's going to be changing a different amount of voltage input to our link, and it's going to be between 0 to 5 volts. That's why I've selected 0 to 5 volt. And then in my label here, I'm going to be calling this trim pot boost. Click OK. So now we have that labeled. And I'm going to be going here. I'll say yes, I want to delete that since I've already set it up. I'm going to go into my parameters list, my live parameters list. I'm going to go in here, right-click properties, and I'm going to be adding that into this so I can see the status of it, just like we saw the status of our switch. So when we're pushing our switch down, it was changing the status from off to on. I want to see when I have my trim pot, what I'm going to be doing here. So I'm going to be typing in trim and then allowing it to populate and find that I've just labeled it. I'm going to give it, here we go, trim pot. We're going to be CAN6 and the status, and we're going to go here and add them to our list. And now we're going to see that they're added. So we can see the voltage level of my trim pot. It's on the first click position, so it's roughly 0 volts. And my trim pot here is saying, okay, it's seeing the status. So what I'm going to do is jump into my boost table ratio table here. And I'm going to go in and I'm going to click on the table and click X. That's going to bring up my actual axes here. So what I'm going to be looking for is going and double clicking. I'm going to be setting my axis not on my multi-fuel blend for ethanol. I'm going to be setting this on my trim pot. So I have different levels of the lookup or the percentage to my trim pot position. So I'm going to be jumping in. I'm going to be typing in here trim. I'm going to be looking for my trim pot right here, trim pot. And I'm going to be setting my values in my table or my breakpoints in my table to each position of the actual trim pot. So that when I click it, it's going to have a different value associated with that particular breakpoint. So I'm going to be going here, in my first position, I'll have it at 0 volts. My next, I'll do 0.5 volts. My next, I'll do 1 volt. My next, I'll do 1.5 volts. My next, I'll do 2 volts, 2.5 volts, 3 volts. Now, depending on what your trim pot you're using, it'll have a data sheet showing you what the different amount of voltages to each click position is going to be. In my case, that's what it ended up being with this. So we can see that the table is defined here, voltage on the top scale, the breakpoint scale, and then the values in it are percentages. And it's going to be a percentage of what comes from these tables. So to make this really clear, let me just go and highlight all of the values in the table so we can kind of see how this is going to work. I'm going to be setting these all to, let's say, 20% in my Wastegate 1 table. My Wastegate 2 table, I'm going to highlight all the values here. And I'm going to go in and I'll set them to something like 90%. So we have clearly two different duty cycle tables set up here, the completely different duty cycle values in the table. Now what we notice is when we're using this interpolate between, it's going to be doing Wastegate 1 active and Wastegate 2 active. So both tables are active. We can see active boost table, interpolation between 1 and 2. So depending on what this percentage is here, it's going to be starting to weigh the percentage multiplier against the second table. If we get all the way to the top here at 5 volts or the full click position, we'll be at 100% of this table, and we can see here 0 or 0% and 0 volts. We're going to be seeing that we're on this table here. So our reported output here is 21 because we're slightly above here. My boost trim is at 0.8 volts, 0.08 volts. So I'm going to go here. I'm going to take my first click position, and I'm going to be putting it to my second click position. So right now in my second click position, we can see the duty cycle is at 26%. It's taking 10% of my 90%, and it's averaging this 20 against my 90 and giving me this 10% value gives me 26%. So my next click, if I click the next position 3, we see 34%. Click the next position, now we're at 42%. Next position is going to give me roughly 48. Next position here is giving me roughly 55. Next position 61, and so on and so on. If I keep clicking all the positions, we're going to be finding that right now we're at essentially 90%. So we're on our last click position. And we're going to be able to go in and use this as a driver in-cabin adjustment that we're able to go in and set up a boost by ground speed or boost by non-driven speed table, and we can have each click position adding additional duty cycle or additional boost. So we have a tremendous amount of flexibility with this kind of configuration. So you can see there's multiple ways that we can set this up and work. And normally what I do is use a trim pot because they're relatively inexpensive. They're between $20 to $40 to $50, And we have that ability to have 4 positions or 8 positions or 12 positions of adjustment for our boost, and we can set up the increments of control depending on what we set our duty cycle up here. So if I have my table here set at something like 20%, and maybe I only want to bias this table to 50%, it would then go an increment between 20 and 50% depending on the multiplier here, the ratio it's looking at, depending on the voltage click position we're looking at. So how you want to set this up in open loop mode is up to you, but you have the ability to go in and define this, having 2 different axes here, or 2 different tables, should say, 2 completely different boost duty cycle outputs, and have 2 completely different boost profiles, and you have up to 12 positions of adjustment. So you can have it being 1%, or I'm sorry, 1 psi increment increases every click position, or you could have it being 5 psi, or whatever you'd want. You also could have it so that maybe first and second gear here, we're going to be finding that between each table is going to be the same amount of boost if we made them the same. But third gear and on, we might find that if we just go here quickly, let's set these all the same. Actually, jump into the table here. If we go in and we highlight this table and we set our first and our second gear here to 20%, and if we're going through our click positions in first and second gear, it's going to be locked out to whatever between both these tables. But then when we get to third, as we go through the trim pot value here and start to increase it, we're going to be finding that we can vary the boost from third gear and on. So again, there's a lot of flexibility. I'm just giving you a bunch of examples as I'm kind of looking at this. I do use this the most frequent when I do the boost control, again, with the link, because it provides so much flexibility. So the last thing we really have to go over here is going to be these wastegate trim tables here. So we're going to be seeing we have this air temp, coolant temp, and then the gear correction tables. And what we have to keep in mind with these, they're a percentage of correction. They don't go and alter the actual duty cycle value directly. They're going to be a percentage of whatever's coming from the duty cycle table. So we can see right now our wastegate duty cycle is being reported here at 20%. And we're going to be seeing that my intake air temperature here, I'm going to be showing I'm roughly at 32 degrees. We can see IATs here at 37 degrees. Intake air temperature. At the colder air temperatures, you're going to have less duty cycle because it's going to have more ability to produce boost compared to a warmer temperature. We're going to have greater air density, and the turbocharger is going to build at least 1 to 2 pounds of boost more in this colder air. So we have to reduce the duty cycle. So what I would normally do is probably go in here, I would go and tune my vehicle in whatever air conditioning that we're going to be operating in. So if we're going to be in a hot climate, and we're going to be tuning, and we notice that our air temp is between, let's say, 86 and 104, then as I get down into the lower points here in my temperature range, I'm going to have to definitely reduce some percentage. And as I go up here in temperature, I'd have to increase it. So if I tune my engine, let's say, between 68 and 104 degrees in this range, it was my normal operating range, I would leave this 0. But here at 50, I might go and take out 10%, and then here at negative 32, maybe I take out 20%. And what we can see here, and we're looking where I just typed that value of negative 20%, we can see that our table is showing us 20% duty cycle, but now going through this modifier, it's showing now that the wastegate duty cycle is going to 16.6. And if you look at the IAT wastegate trim here, it's showing negative 17. It's interpolating between 32 and 50 degrees here, between negative 20 and negative 10. So the values we put in here are going to percentage offset to whatever is reported from the table. If we get down to really cold temperatures, maybe we type in something like negative 35. This is going to be a little bit of trial and error. You're only going to be taking away as much as you need to be able to set this table up. And then as we get up to the hotter temperatures here, something like 284 degrees intake air temp, which is going to be outrageous. But if we got up that high, maybe we'd have to add 20%. And then as we kind of go back to the table here, we would use Shift H and interpolate some percentage. We would only fill in as much again as we need it. So as we got hotter air temps, if we notice that the boost dropped a little bit, we could add a little bit of percentage modifier, which then would increase this and not decrease it. So it would actually be the opposite of this. So if we kind of went up here in our air temps, and we got a little bit hotter, let's go in here and operate right around in here. We can see now it's showing 20.8% duty cycle because I have this 4% modifier here. So we have the ability to offset it based on our density changing with our air temperature. Now the same thing we have going on with our actual wastegate trim map here for engine coolant temp. Now on the colder coolant temp ranges, I'm definitely going to go ahead, let's jump into this table, I'm going to want to go ahead and turn this down. I don't want any boost being built on a cold engine. So from something like 100 degrees coolant temp and below, I would probably set this to something like negative 100. And what we can see here immediately shows a negative 100. My duty cycle goes to 0. It's going to effectively block it out. But then as I get up to my warmer temperatures, my normal operating range, let's say from 122 to something like 212 Celsius, or I'm sorry, Fahrenheit, we're going to be finding that we're going to go and operate in the table here. And let's go ahead and bring it up into that range. Let's go, and we're going to be seeing now the duty cycle goes back to normal value. We're going to see that the trim zeroes out. And then if we get to really hot temperatures, we go to starting to overheat, we obviously don't want to run any boost that could damage the engine. So at something like 230, maybe I want to take 50% out, and then between 230 to 284, use Shift H, go ahead and do a blend here. And as we get up to the really hot temperatures, we're going to be finding here that we're going to go in. It's hard to repeat this on the simulator here, but we can see right now our wastegate trim here is negative 80, negative 79. You can see our wastegate duty cycle drops. We want to basically drop our duty cycle out. We don't want it to, the engine have any damage as it's overheating. So we'd set our table up something like this, so it really drastically reduce the duty cycle. Now our last table here is going to be our boost gear wastegate trim. So depending on what our gear position is going to be registering here, we have the ability to either add or subtract our duty cycle or percentage, just like we found with these tables. So it's going to act in the same manner, just based on gear. So if we did not have this table based right here on gear, and we wanted to have only a two-dimensional table, we would have this boost wastegate trim table here to help us shape the table. Now, the difference here is going to be that this table has the ability to ramp the duty cycle per different gear. This is going to have just a static value here of an adder or subtractor based on the gear. But we do have the ability to do this on gear. So if we had a simple table here, let's say it was based on engine RPM and throttle position, and we wanted to vary the duty cycle in each gear to get more or less boost, we could just do that with this table and not have to maybe turn it into the three-dimensional table. Maybe we only want to have it based again on ground speed. We could set it with lose this gear position here and take it up in the table, but it's not going to be as much resolution. But it is the same way we can apply things. We can either add or subtract based on gear, so this can be another way we can do our trimming. So this is pretty straightforward here for our boost control and open loop method. We're going to be looking at closed loop next. There's a little bit more to it, but now that we've learned how to work with our boost control and open loop, we're going to be able to apply everything to closed loop, and we're going to be finding that it's going to make a lot more sense when we get into that video.
All right, so that wraps up our open loop style boost control training we're going to be finding with our Link EMS. Hopefully you found this video really helpful and you're able to utilize it in your tuning. Now, if you like what you see here, make sure you subscribe to our channel. If you want to learn more about working and tuning with your Link EMS, make sure you check out the link in the description below. It's going to be evansperformanceacademy.vhx.tv, and that's going to be our online training course they're going to be having for this Link EMS, along with many other major engine management systems. Now, if you go there, you can have a 3-day free trial to check out all the other content and videos we offer to see if it's going to be right for you. So hopefully you like what you see, and I'm going to be able to see you guys in class.